All right, now we are starting. So we had a little warm up here, so we're going to take it all the way through here. So let's take this function all the way through, and then we're going to get harder and harder. And as I mentioned before, I'm going to repeat myself just because now I'm recording. We're talking about points of inflection, and a point of inflection is where a graph changes concavity. Okay, and you're going to find now first and second derivative. So what we do is we do a sign chart for F1. This is going to tell me increasing, decreasing information. And then we do F2. That's going to tell me concavity. All right, and again, when I set them both equal to 0, I get x equals 0 in both cases. All right, but on here, I get positive, positive. So that just tells me it's increasing everywhere. Remember, all this information describes the original function, okay? Concavity, I plug in here, I get negative and positive, so that's concave down, and this is up. Well, if we can take all this information right here, we can figure out a curve sketch from this. Yes, Chris?
Okay, so the second derivative determines
concavity. Yep. All right, so here we go. So if I was to take all this information at 0, I'm increasing everywhere, and I'm concave down left of 0. So that would be kind of that. And now I'm increasing still, but now I'm concave up. And see, all that information kind of fits. And we know that to be the graph of x cubed. Okay? Now, what I'd like for you to do is kind of start seeing some graphs on top of each other here. All right, so what I've done is I've graphed x cubed, 3x squared, 6x. I've got all my derivatives here. Okay? So what I'd like to do is red is my original, blue is my first derivative, and green is my second derivative. All right, these are some observations, guys, I need you to understand. Basically, a function is going to be concave down where first derivative is decreasing. I'll let that really sink in, that statement. Think about it. It's when I'm decreasing, notice that I'm decreasing here on first derivative. That means I'm concave down. So think about it. Think of the second derivative, really the first derivative of the first derivative. The second derivative is the first derivative of the first derivative. Okay, so if this is the first derivative, if I differentiate that, that's here. So that's just one derivative away from this. So remember, we're talking about what is a slope. When you differentiate at points, there's slopes of tangent lines. So what's happening is, think about it, I've got negative slopes here on the derivative. That means what that translates to, guys, is that's the concavity of the original. So, all right, now let's look at increasing. Look how blue is positive everywhere. See how blue's all above in the positive y? If blue's positive everywhere, that means the red is increasing everywhere. This is really kind of like make your head hurt stuff, okay? And I don't know how else to explain this, but just to show you a bunch of pictures, okay? And try to get the logic across to you. Again, red is my original function. That's what we're talking about. We're talking about the concavity and the increasing, decreasing nature of my red function. That's the original function. This blue and green is just information, guys. So the blue is my first derivative. So again, I'm talking about, see how it's positive everywhere? I'm not talking about increasing, decreasing. I'm just simply look at the y values for all the blue. They're all positive. That means my original function's increasing everywhere. Now, let's talk about concavity. Notice that blue is decreasing left of 0. So if it's decreasing or negative, that means I'm spill water on the original. Okay? Also, look at green. Green is my second derivative. See how green is negative down here? Look at all the y values down here. All these y values are negative. That means I'm spill water as well. So there's two ways to look at concave down. First derivative is decreasing. And or second derivative is negative. Both mean the same thing. So that tells me it's concavity. And you don't have to use both. You use either or will give you the information. Now look at green here. Look at all the y values. All the y values are positive. That means I'm hold water on red. Okay? All right. I want to do a little exercise here. We're going to do some mini exercises. And we're going to see if we can kind of get this concept down. All right. Yes. Yes.
How can you tell the turning point is 0 instead of upper than 0, 3 or 4?
Well, you're guaranteed by the math because we only solved it. We only got 0 as an answer. So you can be assured it will never turn or nothing else will happen everywhere else. Okay? Since we set first derivative equal to 0 and second derivative equal to 0 and we only got 0 as an answer, you can be assured that that's the only critical point. That's the only point where something weird's happening. And sometimes it can be a max-min. In this case, it turned out to be a point of inflection. All right. Yes? We don't do third derivative. We do second derivative. So green is, this is the original, first derivative, second derivative. I know what you're talking about, the third function. Yes. Right.
If it's whatever negative value you get,
It's spill water. Yeah, that's where it's concave down. So notice I'm negative here. Here's my green one, which is my second derivative. All the y values are negative. That means for all that area, my original function is going to be concave down. Now green is positive here. Notice I'm hold water now. I'm concave up. Everything's talking about the red function. Red is what we're talking about. Yep. It does help me. It tells me that, all right, look, I'm decreasing everywhere. So that means it's also telling me about concavity. Where first derivative is decreasing, the original function would be concave down. Wherever first derivative is increasing, I'm concave up. Both bits of information tell you the same thing. So second derivative, I can just look at it's negative, concave down. First derivative is decreasing, concave down. Okay? Notice that the blue, the y first derivative, is positive everywhere. That means it's increasing everywhere. Okay? You just got to look at kind of what the information we're doing here. Let me plug in real quick. I'm getting a little low on battery. What I'll probably do is I'm recording this. I'll post this, but I'll record it again fourth period because I may say some other information, and we'll put them all together and just hopefully you have enough information. All right, I want to do a little exercise with you guys. All right, I'm going to put a chart here, and I want you to tell me some information here. So I've got an interval here. All right, so we're going to between negative infinity and negative 2. My next interval is negative 2 to 2. And my last interval, 2 to positive infinity. Okay, I'm just going to give you some information here. F double prime of negative 3, that's a test value, okay? We'll call this test value. X equals 3. All right. I'm going to say f of negative 3 is greater than 0. Here I'm going to let my test value be 0. So f double prime of 0 is less than 0. And then here's my test value, x equals 3. I'm just picking numbers in this interval up here. 0 is between negative 2 and 2. 3, whoops, this should be negative 3. Negative 3 is less than negative 2, and positive 3 is going to be greater than 2. All right, and f double prime of 3 is greater than 0. Tell me the concavity. I'm not even telling you a function. All right, and then by the way, I've got, we're going to have a couple of these on the quiz Friday. All right, I'm not even giving you a picture. I'm not giving you, there's no even function. You don't even know anything. But based off definition, what is that? What can you conclude? In this interval between negative infinity to negative 2, is it concave up or concave down? Concave up, why, Ari? Because it's greater than 0. Because it's positive, it's concave up. All right, and then this is saying what? Ty, what is that saying right here?
It's less than 0.
So it's negative, so what's the concavity?
Down.
It's down, okay? All right, and Kenya, this is what is this telling me right here? F double prime of 3 is what? And so it's positive, so what does that tell me about the concavity? It's up, okay? It's positive, so it's up. Very good. Okay? Yes? What? Up can be kind of like, yeah, I mean, I know it's kind of hard to concept up, but it's kind of can be like that. You know, more exaggerate like this. All right? Downs are going to be like, okay, these are kind of like ups. All right? In other words, the slight bit of curve, you know, if it's just a slight bit of curve, you know, if I'm kind of pointing up like that, that's concave up. Some of them are exaggerated, and they're really, you can tell they're up. Okay? Down, you know, even if it's like that, that's still down. All right? More exaggerated. All right? Yeah.
Okay, so I don't attach the match the graph with the equation, or we go into the graph.
So for test, I'm going to ask it like 4 or 5 different ways. I'm going right now through all the ways I'm going to ask it. First thing is I'm going to give you no function, no picture. Just going to give you a chart of intervals and some test values and tell you the result of the test values. You have to fill in this squares. You're going to tell, and so you can interpret that this sucker is positive, so it's up. It's negative, so it's down, and so forth. That's one way I'm asking you. That's one way the AP exam, I've seen this question on an AP exam. They give you no function, no picture. They just give you some data. And I can expand this data. I can have another part, F prime. So you're going to have to tell me how. Is it increasing, decreasing, up, or down? Okay? All right, let's do one more, and then we're going to keep getting harder and harder here. Here's an interval. I've got negative infinity to negative 1. Negative 1 to 1, and then 1 to infinity. My test value is going to be x equals negative 2. I'm just picking any value in this little interval. Here I got x equals 0, and here I have x equals 2. If I tell you f double prime of this test value is positive, what can you tell me about this interval? Concave up. Okay? If I do f double prime of this test value and I find that it's less than 0, that is down. And then if I do of this test value, f double prime of 2, and I know that's greater than 0, that's up. Okay? Now we're taking this slow, okay, guys? We're leading into a lot of stuff coming up, but I don't want to, just run in 100 miles an hour. Yeah, Dylan.
Will there ever be something where it's like greater than or equal to 0?
No, because at those points we know it is 0. Remember, because we said equal to 0. These are the magic points here, negative 1 and 1. And remember, how did you even get the negative 1 and 1? You took the derivative or second derivative, set it equal to 0. So we know at those points it equals 0. So we don't want to test the actual point negative 1. So that's why I go less than negative 1. Okay? I don't want to equal those endpoints. All right, let's keep going, guys. All right, I think you've got that. All right. Now, here's a cool thing. Yeah. Yeah.
It's up, down, up. I'm just trying to figure out, like, where's 0?
So we got up, down, and then up. So something that could look like that. Let's see here. Well, again, I'm just making up stuff, but it could look like, here. This could be it. Okay. Oops. That could be my negative 1 and 1. So I'm up, down, and now I'm up. That could be negative 1. That could be positive 1. So there's a sample graph of that demonstrating there. Okay. Now I can have a max here in between here, but I'm concave down everywhere. If you look what a max is, you're going to be concave down everywhere inside that, on the left and right of that max. And on a min, you're going to be concave up on both sides of that, on that min. Okay? All right, here's a cool thing here now. There's this thing called the second derivative test for max and min. Now we've been saying, all right, first derivative tells me, hey, that tells me increasing, decreasing nature of a function. Then we just learned second derivative tells me these point of inflections where it changes concavity. There's this cool rule called the second derivative test for max and mins. Remember when you were trying to find a max or min? Let's try 3x squared. That's my original. Okay. Y prime would be 6x, and y double prime is 6. Okay. I'll get a better one here in a minute. But let's go through the steps here again. I know it's a simple one, but sometimes when you use a simple function, you can see it easier here, and it saves some time on work. We know this is a parabola. We know that it's, when you set it equal to 0, you get x to be 0 for first derivative. So what is that? That's a critical point, right? This was a CP. And we would test on the left and right of that critical point. And you'd plug it into the first derivative. Put a negative 1 into the first derivative. I get a negative. Duh, it's decreasing. We know that. Pick a point to the right of 0. I get positive. Duh, it's increasing. What's cool now, there's a new little test. See how we had to test all these intervals? There is a way to test the actual point and find out if it's a max or min. It's called the second derivative test. And all you would do is, instead of testing the intervals, you plug that 0 into the second derivative. If it's positive, it's concave up. If it's negative, it's concave down. Okay? Let's do a more complicated one here. Now, by the way, this is a constant. So it's positive, so that means that point is a min. Okay? If it's positive, I'm sorry, I got that reversed. Your common sense will say if it's positive, it's going to be a max. If it's, all right? If it's positive, you've got a min going on. Okay? You're changing from, I meant to say decreasing to increasing. If you have, all right, let's write it down. If it's positive, it's a min. And if it's negative, it's a max. It's kind of opposite of common sense. Let's do a harder example here. Let's do... All right, here's a good one. Let's take this function all the way through. 3x to the 5th plus 5x cubed. All right, here we go. Let's go ahead and find everything we can find here. Let's find first derivative. That's going to be negative 15x to the 4th plus 15x squared. Let's set that equal to 0. Let's factor out a negative 15x squared. I'd be left with x squared minus 1. All right, so I'd get 0, comma, negative 1, comma, 1. I get 3 solutions. These are critical points, CPs. Now, what did we do? We would do a sign chart here. We'd lay these guys out, and we're going to find out if they're maxes and mins. Okay? Now, before I do that, let me go ahead and find second derivative for the kicks, for fun of it here. So we get negative 60 x cubed plus 30x. Okay, and if I clean that up, if I factor out a 30x, I'm left, or negative, I get a 2x minus 1. Whoops. 2, yep, thank you. 2x squared, Negative 30 plus, yep, there we go. All right, let's solve this now. Now here, we get x equals 0, and x equals plus or minus the square root of 1/2. Agreed? Guys, we call all these guys critical points. Again, a definition of a critical point is some point where something weird is happening. Now notice 0 appears in both groups. Okay, so we found 0 by the first derivative, but we found 0 by the second derivative as well. So we got to figure out, is 0 a point of inflection or an extrema? All right, so I'm going to throw these values in here. All right, now what we would do, let me put it on another graph here. Hold on. That's my first derivative. And then so we don't crowd it. And that's my second derivative. All right, and then what we did is we would test the intervals, didn't we? We'd test this guy, and then decide if it's a max or min based off of if it's positive, negative, or negative, positive. Second derivative test for max and min says this, though. I can take this right here, plug it into second derivative, and see. Let's see what I get. What's negative 1 cubed? Negative 1 times negative 60. It's a positive 60. And then 30 times negative 1 is minus 30. Point is, I get a positive. If it's positive, it's a min. That's a lot easier than having to plug in two values on either side. Now we're going to do it old school here in a minute, but we're going to just try this new way. Let's plug in 0. Right? We got to pretend we don't know 0 is a point of inflection actually. But according to our information, first derivative yielded a 0, didn't it? So for all we know, it could be a max or min. Let's plug it into second derivative. I get 0. It's not positive, it's not negative, so we know it's not a max or min. Let's plug in 1. I get negative 60 plus 30. I get a what? Negative. So 1 is a max, okay? Because f double prime of negative 1 is greater than 0, and then f double prime of 1 was less than 0. I know it's a lot to take in, guys, and you're going to have to do a bunch of these, but we're going to take our time. I'm not going to rush through this stuff. Now we're going to talk about concavity, okay? This is where points of inflections happen. All right, let's pick a value to the far left of negative square root of 1/2. All right, let's pick negative 2. All right, so I'm going to do f double prime of negative 2. So negative 2 squared, or negative 2 cubed, would be what? Negative 8. Negative 8 times negative 60, positive 480, okay? And then negative 2 times 30. The point is, I'm positive there. That's all I care about. I'm trying to do this without a calculator. All right, because we need to be able to kind of analyze this without one. Yeah. Theoretically, they could all be. Sometimes they're not all max and mins. Right. By what we're doing right now. Okay, so remember, from first derivative, I had 3 critical points. I just tested 0 to be, the second derivative test, and I yielded 0, so I don't get positive or negative. Let's pick a value here. All right, let's do just on either side of 0. Okay, so I guarantee you're going to get positive for both. All right, but let's test it out. How about negative 1/2? All right, negative 1/2 x cubed. What is that? It's going to be negative 1/8. Point is, you're going to be negative times a negative. You're going to be positive 60 over 8, which is about what? 7 point something. So positive 7 point something. Okay. positive 7 point blah, blah, blah. All right, and then what's 30 times, it's going to be about negative, right. Oh, I'm sorry, you got to go first derivative. I'm sorry. Anything squared, anything to the even power is positive. All right, so if I did, negative 1/2, it's going to be basically negative 15 halves. Remember, we're talking about increasing, decreasing. And then negative 1/2 cubed is going to be, it's going to be, positive 1/8, so positive 5/8. No, negative 5/8. So actually I'm negative here. Wait a minute, how can that be? Let me get a... Well, remember, I'm talking about the increasing, decreasing, okay? And let's go plug in here a table. All right, let's go get some values because I can type this in a lot quicker. Clear. All right, so we're going up to negative 3x to the 5th plus 5x cubed. All right, let's put my second derivative in. Negative 15x to the 4th. What do you mean? I meant first derivative, second equation, y2. I meant to say the second one. I'm just going right down the list. I'm letting y1 be the original, y2 be the first derivative, and y3 is going to be our second derivative. Plus 15x squared. All right, and then let's go down here, negative 60. X cubed plus 30x. All right, let's go up to table. No. Quit. There we go. Delete, delete. All right, now let's go through here. Oops, I got two of these suckers open. All right. So I've got my first derivative chart here. All right, and let's pick some values here. Let's go to negative 2. I'm really just interested in, oh, this only does 2 columns. All right, so I get negative over here. Right? And then on the other side, let's do negative 0.5. I'm positive. And remember, we knew that. Going from negative to positive was a min. All right? All right, so y3 is in there. So this won't even do. Can I scroll over? Ah, there it is. All right, so, all right. I was just kind of curious. So let's plug in actually negative 1. All right, and I'm really interested in y3 column. Now look, I get 0 for the second one, right? Because we knew that. That's a max or min. Let's go over to the third column here. I get a positive. And if it's positive, it's a min. So let's recap here, guys, everything that we've done. Let's look at this information right here. Guys, I know it's not the most exciting stuff, and I know I'm not exciting here, but this is a necessary evil. Doing it old school, we plug it into the first derivative. I get a negative over here and a positive here. Okay, that tells me it's decreasing, increasing. Well, we know that's a min. Our new rule today says actually take the value there, the negative 1, put it into the second derivative. If it's positive, it's a min. If it's negative, it's a max. Okay, so we did that here as well. So you can see right here, second derivative yields a positive. So that's why it's a min. But looking over here, All right, here's -2 and -1/2. That's on either side. That's also showing it's a min by the first derivative. I get a negative and a positive. Negative, positive. All right, let's pick a value just to the right of 0. Let's pick positive 1/2. 0.5. No. 0.5. Let's analyze what we got here. In first derivative, I'm on positive. Okay, so that tells me 0 is not a max or min. It's not an extrema. I'm increasing right through it. All right, but if I pick a value just to the right of 1, let's put in 2. Notice first derivative is negative. All right, going from increasing to decreasing yields a max. And if if I find the second derivative at that point, let's put in positive 1. Look what's happening to second derivative. Second derivative is the third column. I'm negative. And since I have a negative, that makes it a max. So in summary, 2 ways to find a max or min. Old school, we just do a line chart. We test the intervals on the left and right of the critical points. Now our new way is we take the actual critical point, plug it into second derivative. If we get a positive, it's a min. If it's a negative, it's a max. That's the only thing that's opposite of common sense. Our brain wants to say positive is max, but it's not. All right, that's all about increasing, decreasing, max and mins. Now let's continue this, and let's figure out, we've got these points of inflection here. Let's pick a value to the left of negative square root of 1/2. All right, I'm gonna use the value -1 here. All right, what is the square root of 1/2? Small number. Okay, so look, I'm gonna go to -1 and look at what my second derivative yields. Positive. See? Positive means it's concave up here. Let's pick a value in between 0 and that. Let me find the exact decimal equivalent of square root of 1/2. So we make sure we don't. Okay, 0.707. All right, so I got to find something. So we can just hit 0.1. All right, so I'm going to go back over to here, and I'm going to pick a value in this interval right here. So I'm going to pick -0.1. Okay, let's go to third column here. I get a negative here. So I'm concave down here. Now, what's the definition of a point of inflection? Changes concavity. Do I change concavity here? Yep, I'm going from up to down. Bingo. That is a point of inflection, a POI. Now let's test just to the right of 0. What's that? So I'm going to do 0.1. Yes.
I need point one, like, how do you do it with x point 1? So it's just giving me like 0, 1, 2, 3. Oh, okay.
All right. Yeah, she can show you. We wanted to ask us, not choose for us. Table set. See where it says ask? Just highlight ask. Now you can enter your own stuff. Okay? All right. Now I put in positive 0.1. Now I'm going to go look at second derivative, which is my third column, and I'm positive. So now I'm back to up. Is 0 a point of inflection? Yes, it changes concavity. And guys, we're going to take all these pluses and minuses, and we're going to try to come up with an idea of what this thing looks like. All right, and that's what curve sketching is about. All right, let's pick a number greater than that. So I'm just going to I can do 2. And again, I go to my third column, and I'm negative. So I'm down again. All right, guys, let's see if we can take all this information and piece together what's going on here. All right, I'm going to put my extremas in red, and I'm going to put my points of inflection Let's do green. All right, I've got 0, and I've got negative square root of 1/2, and positive square root of 1/2. All right, here we go. Everywhere left of -1, I'm increasing, and I'm concave up. Okay, I'm increasing, concave up to -1. Is everyone okay with that? Now, between -1 and 0, I'm increasing. Oh, I'm sorry. I'm decreasing, concave up. My bad. Decreasing, concave up. That's because of the negative right there. So everything left of -1, I'm decreasing, concave up. Now, I still have to go all the way up to, I'm still concave up all the way over to negative square root of 1/2. All right? So I'm going to keep going.
We're using the first.
But everything to the right of -1, I'm increasing. So now I'm going to be increasing, still up. Again, left of -1, I'm decreasing up. Bam. Everywhere to the right of -1, all the way up to 1, I'm basically going to be increasing from now on all the way over to here. Okay? But I'm increasing, but now as soon as I hit negative here, I'm going to switch to down. Okay? But I'm still up. I'm going to exaggerate it. I'm going to put little arrows here. Should have gave myself more room, but anyway. So all the way up to 0, I'm still increasing, but when I hit 0, I'm down. Now when I hit 0, I'm gonna hold water. I'm gonna concave up, but I'm still increasing. So that does this. I'll put a little point here, and now I'm increasing. Oops. Okay, I'm increasing, but now I'm hold water. I'm concave up. Soon as I hit 1, or let's see here. Let me make my points match up, and let me give myself some more room. I'm running out of room here. All right. There we go. All right, so let's come down here. Yep. All right.